Let's discover together the hypothesis testing for a population mean. Let's solve the following problem. A math professor believes that the mean price for graphic calculators is less than $140. In a random sample of 50 graphing calculators, the mean price was $125. The population standard deviation is $28. Use a 4% significance level to test the professor's claim. In this problem we have to test the claim that the mean price for graphic calculators is less than $140. We'll solve the problem using the hypothesis testing method, which is based on reductio ad absurdum, the Latin name of a method of proving a statement. The hypothesis testing method starts with an assumption. If the assumption, through logical deductions, leads to an absurdity, then the assumption is rejected and an alternative, a negation, of the assumption is accepted. What if that through logical deduction we do not get an absurdity or a contradiction? In that case we say that there is not enough evidence to reject the assumption. The statistical hypothesis testing can be compared with a judicial trial. In a trial, the assumption is that the defendant is not guilty. The alternative is that the defendant is guilty. If the trial can prove guilt beyond a reasonable doubt, then the assumption is rejected and the alternative is accepted. In this case, the trial proves the defendant guilty. How can we measure the possible error in this case? In statistics, this error is called type 1 error. Type 1 error is made by rejecting the assumption, when it is true. The probability of type 1 error is denoted by alpha and it is called significance level of the test. In a trial, type 1 error leads to sentencing a defendant even though he is not guilty. If the trial cannot prove guilt beyond a reasonable doubt, then there is not enough evidence to reject the assumption. You are stuck with the assumption even though there is only lack of strong evidence against it. Type 2 error is made by not rejecting an assumption, when it is false. In a trial, type 2 error leads to not sentencing the defendant, even though he is guilty. The given in this problem are a random sample of size 50. The sample mean is $125. The population standard deviation is $28. We have to prove the claim that the population mean is less than $140. Let's start with the assumption that the population mean is equal to $140. The assumption, denoted by H sub 0, is called the null hypothesis. The null hypothesis is always a statement stating that the population mean equals the hypothesized value. The sample mean is a random variable, as the mean of the sample varies from sample to sample. The central limit theorem describes the sample mean distribution. Because n is larger than 30, then the sample mean distribution is approximately normal. As the population standard deviation is given, we can make x bar into z. The test statistic is z out of a sample mean value. The computation for z leads to a test statistic z equal to -3.79. We started with the assumption that the population mean equals $140. The given sample mean value of $125 was converted into a z value equal to -3.79. The 4% significance level, the 4% area under the left tail, determines a critical value z equal to -1.75. The critical region is made of z values less than -1.75. If you compare the chances of getting a z less than -1.75, 4%, to the chances of getting a z more than -1.75, 96%, then you may think that getting a z equals -3.79 has very slim chances of happening, less than 4%. Something must be wrong. Our reasoning was based on the population mean equals $140. Therefore, that assumption must be wrong. So, we reject the assumption, the null hypothesis, and accept the alternate hypothesis. Let's talk about type 1 error. Rejecting a null hypothesis which is true leads to type 1 error. In our case the probability of type 1 error is 4%. Type 1 error happens because 4% of sample means values, converted to z, are less than -1.75 when the population mean is equal to $140. Let's solve this problem again, emphasizing the 5 steps of this procedure. We have to prove the claim that the population mean is less than $140. Step 1 is about identifying the null hypothesis and the alternate hypothesis. The null hypothesis is a statement saying that the population mean is equal to $140. The alternate hypothesis is a statement saying that the population mean is less than $140. The alternate hypothesis, denoted by H sub A, is a statement that can take one of the following forms, based on what we want to prove. The population mean is less than the hypothesized value and the test will be known as a left-tailed test, or the population mean is more than the hypothesized value and the test will be known as a right-tailed test, or the population mean is different than the hypothesized value and the test will be known as a two-tailed test. Step 2 is about the significance level. The significance level is 4%. Let's visualize the level of significance denoted by alpha, based on the test's type. For a left-tailed test, the level of significance, denoted by alpha, is the area under the left tail of the z distribution. For a right-tailed test, the level of significance is the area under the right tail of the z distribution. For a two-tailed test, the level of significance is split between the right and the left tails of the z distribution. Step 3 is about making an assumption. We'll proceed by making the assumption that the null hypothesis is true, therefore the population mean value is equal to $140. Step 4 is about choosing a test statistic, a value from sample data. Because n is larger than 30, then the sample mean distribution is approximately normal. As the population standard deviation is given, we can make any x bar into z. The test statistic is z out of a sample mean value. The computation for z leads to a test statistic z equal to -3.79. Step 5 is about finding the critical region and stating the conclusion. What I describe under step 5 is called the classical approach. The level of significance is visualized as the area under left, right, or both tails based on what hypothesis test we have. This value will determine the critical region. If the observed value of the test statistic falls into the critical region, then the null hypothesis is rejected and the alternate hypothesis is accepted. Please recall that we have to prove the claim that the population mean is less than $140. The test we'll perform is a left-tailed test. The area under the left tail is 4%. The corresponding z-score is -1.75. The critical region is made of values less than -1.75. As you can notice on the graph, the observed test statistic z equals to -3.79 falls in the critical region. We reject the assumption, the null hypothesis, and accept the alternate hypothesis. At 4% level of significance we have proved that the population mean is less than $140. How do we find the z value such that the area to its right is equal to 4%? Z sub 0.04 is the notation for the z value such that the area to its right is 4%. From the unknown z-score toward the right tail, the area is 4%. The z-table reads the area under the left tail. The area under the left tail is 1 minus 4%, which is 96%. In the z-table, an area close to 0.96 is 0.9599, which corresponds to a z-score of 1.75. The z-value having 4% area to its right is 1.75. Because the z-distribution is symmetric about 0, the z-value such that the area to its left is 4% will be -1.75. Thank you for watching.